I'm Anil Kumar, and here is question number 7 on average rate of change. Water is draining out of a conical tank at a constant rate of 4 feet cubed per minute. Before the tank began draining, the water level was 12 feet and the diameter of the water surface was 8 feet wide. Calculate the average rate of change in height with respect to time as the water level decreased from 6 feet to 0 feet. That means it emptied, right? You can pause the video, copy the question, think about it, answer, and then look into my suggestion. Well, in this question you'll need a calculator. Let's start with making a sketch of a conical tank. Let's say this is the cross section of a conical tank. It is given to us that height of this to start with is 12 feet. That is to say, this is your height and this height is 12 feet. The diameter is 8 feet. So diameter is 8 feet. So it is 12 feet by 8 feet. Now from here what we can see that the radius on the top will be 4 when the height is 12, right? Now we need to calculate average rate of change in height with respect to time as the water level decreased from 6 feet to 0. So at 6 feet, when the height is 6 feet, what is going to be the radius? Using similar triangles, we can find the answer, right? We see this big triangle is similar to the small triangle. And therefore, what we have here is that the ratio should be how much? We can find from here. We know it is 4 over 12 is equal to, let's say this is R over 6, right? From the similar triangles. So from here we can find the radius for the water level when the height is 6 should be 6 times 4, 24 divided by 12. That is, the radius should be 2, right? So basically they are in the ratio of 1:3, right? So we find that the radius is 2. Now this radius really helps us to find the volume when the height is 6. So we can calculate the volume. So volume is 1/3 pi r square, radius is 2, and height is 6 times 6, right? So this, let's use calculator to find this volume. So it is pi, we could use 3.14 also. Let me just use pi for the moment, times 2 square is 4 times 6 divided by 3, we get a value 25.1327. Now that is the volume. Now volume changes from 25.1327 cubic feet to 0 when the height is 0, right? Now how much time does it take? We know that the conical flask is being drained out at a constant rate of 4 feet cubed per minute. That means rate of change of volume dV over delta T is basically equals to 4 cubic feet per minute. Now if we want to know the change in time when 25.1327 cubic feet of volume was displaced, how much time does this take? We can calculate using this formula, correct? So from here we can find that the time taken should be equal to change in volume divided by 4, right? Should be change in volume divided by 4, correct? So we can find change in time to drain out water when the level was 6 feet. So it is 25.1327 divided by 4. And that gives us, let's divide using calculator, 6.2832. Okay, so that is the change in time. Now we need to find average rate of change in height with respect to time. So that means average rate of change in height with respect to time. This is what we need to find. Height changes from 0 to 6, right? I should say 6 to 0, and the volume changes from 25.1327 to 0. So total change in height is 6 for us. We have 6 divided by change in time is 6.2832. So let us divide 6 by 6.2832. What do we get? We get 0.95. So we get approximately 0.95. So the closest answer for us is D, 0.94 feet per minute, right? So that is how we can calculate change in height with respect to time. Go through this video once again, try to understand the concept, and then move on. Thank you and all the best.